Hi everyone, welcome. Let me get some markers. Hey everyone, welcome back. Uh, I just did a whole 2.5 minute intro, and I was mentioning updates and stuff I'm going to do to the platform, and now I lost all of it, and here we are. Okay, hi. So I'm gonna not do the updates again because why? And we're just gonna jump into it. So today what we're going to be looking at is Lumi's ability to draw.
One pair of pants later.
We're going to start with the geometry regions. So we can see here, right? I'm going to be completely honest. I don't know how to do this. So I think this is the perfect question because I don't know how to solve it. Just like before, going to go to help with my work and just going to upload that screenshot I took. Oh no, something went wrong. Anyway, let's talk updates. So yesterday I also mentioned that I want to take the GREs, but I need to take a diagnostic first. I want to do sort of a before and after to show that Lumi can help someone pass any of these tests. Uh, I want students to use it for tests like the Regents or the SHSAT, and that's because I live in New York, so I don't really know what other tests exist outside of those two. The last time I took the GRE, I think was 10 years ago, and I did not do well. I think I was well below the 50 percentile. But like it's fine. It's fine. I'm much better at math now. I am with all the teaching experience I've had. Okay, Lumi is ready. So,
Hey, Jin. Welcome back. I can see you've uploaded a geometry proof problem about proving quadrilateral ABCD is a parallelogram. The diagram shows the quadrilateral with that extension through D to point E and those intersecting segments at F. What part of this proof are you finding tricky? Or would you like me to help you work through the whole thing step by step?
hey Lumi, I actually don't remember how to do any of this, so step by step would be great. But first, can you draw it on the whiteboard so we can see it?
No worries, Jin. Geometry proofs can feel rusty if you haven't done them in a while. Let me recreate this diagram on the whiteboard so we can work through it together visually. Perfect. Here's the diagram.
Actually, Lumi, I'm using dark mode and I can't really see the black lines. Can you make the lines white so I can see them a little better? Also, point F isn't at the exact intersection. Can you fix that, or is that just not a thing you can fix?
Good catch on both. Let me clear this and redraw it with better visibility. Much better. Now you can see everything clearly in dark mode. The quadrilateral ABCD is in white. The extension to E is the cyan dashed line. And the two intersecting segments, AD and BE, are in yellow with F at their intersection. Now let's tackle this proof. What information does the problem give us to start with?
So you can see that Lumi, I asked to recreate it, and Lumi did a really good job. It's not pixel perfect, but I think that's just a limitation of large language models right now. As the technology improves, Lumi's ability to draw will get way better. Sorry, Lumi, I'm actually talking to the stream. So I can't see the problem because of the whiteboard. Can you tell me the problem again, and then I'll try to fill in what I need to?
No worries, Jin. And thanks for the feedback. You're right that the spatial reasoning will keep improving as the tech evolves. Here's the problem. In quadrilateral ABCD, side CD is extended through D to point E, such that segments AD and BE bisect each other at point F, and DE equals DC. Prove that ABCD is a parallelogram. So the key given information is 1. AD and BE bisect each other at F. 2. DE equals DC. Now, what do you think would be a good first step to start this proof?
Wait, I'm a little confused. A B D E? Isn't it? Don't you mean A B C D? What do you mean A B D E? Oh, am I supposed to draw like missing lines there to make it a quadrilateral?
Exactly. Great insight. Yes, you need to imagine connecting A to B, B to E, E to D, and D back to A. Let me draw that on the whiteboard so you can see it clearly. See the green line I just added? That completes quadrilateral ABDE. The sides are AB, BD, DE, and AE. The yellow lines AD and BE are the diagonals of this quadrilateral ABDE, and they bisect each other at F. So now, what type of quadrilateral must ABDE be?
Oh, okay. So then ABDE, this quadrilateral here, is a parallelogram? No. It's a. You just told me. You just told me. Sorry. It's a parallelogram, right?
Yes, exactly right. ABDE is a parallelogram because its diagonals bisect each other. Now, here's where it gets clever.
Wait, sorry.
Since A
Before you do that, can you draw the line from B to D so I can see it there too? Because I drew it, but I don't see it on the whiteboard, and it's kind of confusing me.
Of course, let me add that BD line to complete the quadrilateral ABDE more clearly.
This proof is only 5 steps. I feel like we talked for 20 minutes. But all right, yes. I do understand that actually makes a lot of sense. To prove something is a parallelogram, you really just need to prove that two of its sides are parallel and the same length. Once you prove that, it's a parallelogram.
Exactly. That's the beauty of it. Once you understand the logic, the proof is actually quite elegant and compact. The 20 minutes we spent was all about building that understanding, figuring out what quadrilateral ABDE was, why it mattered, and how it connected to ABCD. Now you've got the core insight. One pair of opposite sides being both parallel and equal is enough to guarantee a parallelogram. That's a powerful theorem. Do you feel ready to write this up with the reasons now?
No.
Why did I start here? I should have started here. Look, I started in the center, and now I can't. Like, I don't feel like I can use any of these. Why did I do this? I don't know. Anyway, triangles. Let's see. Okay. Uh, yeah, I don't know. I know some stuff about triangle similarity, uh, but I don't know everything. So we'll see. Let's see what happens. Uh, hey, Lumi.
Hey Jin, welcome back. I see you've uploaded a similar triangles problem. Problem 31, with triangles ANT and ELM. You've got all the side lengths listed out. What part of explaining why these triangles are similar would you like help with? Or should we work through the whole explanation together?
Yes, can we work through the whole explanation together? And can you draw the triangles first before we start?
Absolutely. Love the energy. Let's dive in. Let me draw both triangles for you, with all the side lengths labeled.
12 seconds later.
Perfect. Here are both triangles, with all their side lengths. Triangle ANT is in cyan on the left, and triangle ELM is in yellow on the right. Now, to prove these triangles are similar, what do you remember about the ways we can show two triangles are similar?
Okay, so I just want to take a moment and say that Lumi drew these diagrams near perfectly. Maybe the size of the triangles isn't exactly the same as in the problem, but oh my gosh, look at the lines, the points are perfect, the labels are perfect, the lengths, in my opinion, look perfect. Thank you, Lumi. I think what I remember from triangle similarity is we just need to prove angle, right?
Thank you so much, Jin. That really means a lot. I'm glad the visual representation is working well for you. The computer vision system is definitely improving. So, angle A, angle is absolutely one way to prove similarity. You only need two angles, actually. But here's the thing. In this problem, we're not given any angle measurements. Look at what information we do have, just the side lengths. AN equals 6, NT equals 5.6, TA equals 4, and EL equals 9. LM equals 8.4, ME equals 6. So what's another way to prove triangles are similar when you only have side information?
Wait, we can't use sine, cosine, tangent here to prove to find two of the angles and just show that they're the exact same? That's what I was thinking. Well, I mean, you wrote it on the board, so I guess it's SSS, but that means side, 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 which you also told me earlier, so I didn't know it, but thank you for telling me. So I intended to go a little bit longer, but I think an hour is good, given that I don't have any viewers, and man, it's so soul crushing to be here and not have any viewers because I like. Oh, okay, but it's fine because I'm actually genuinely enjoying it. I love working with Lumi. It's actually a lot of fun. I hope that I can inspire kids to want to interact with Lumi and do work in the same way. I use the help with my work feature all the time. I will do the other stuff as well. Like I'll show the other features. I've been having so much fun with this. I haven't been able to, or I haven't. I should just say I'm being lazy about it. But thank you anyone who stopped by. I don't. It seems like no one stopped by, but it's fine. Oh, I'm so sad. Okay. All right. Yeah, I will be back tomorrow. Same thing. Going to be streaming some problems either in a Regents test or on Reddit, and we'll see if I can understand it. If Lumi can help teach it to me. Okay. Thank you, everyone. I will see you in the next one.